to fix anatomy track. Now we have slicing and dicing with cubes, lightweight OLAP framework and server by Stefan Urbanek.
Yep. Thanks. So welcome. How many of you have been to the talk in the morning about cubes, or rather, who wasn't there? So, okay. So I apologize for those who went there. I will go more quickly through the things I've been talking before, while we'll be also trying those things from the morning. So we will like have hands-on. First thing I would like to do is to get the cubes, cube sources and the examples, so we can play with that later on. And if you can just copy the URLs, and I will continue with slides while you would be installing. So if you are ready, just let me know so I can continue. If there are some problems with that, let me know.
It's extremely slow. Exceptionally slow.
Yeah, GitHub is very slow today.
Oh.
It's missing a proxy.
First of all, it's GitHub.
The second one is a little bit bigger repository because it contains database dump. It contains a little bit larger SQL database. SQLite, so you can all try it. There is also a Postgres dump as well included. If you have Postgres, you can try it. So, but SQLite is like common, so this is why it's in SQLite to play with it. Yep. Good question. It is expected to work 2.7. No Python 3 yet.
I mean, it works, but it's just okay.
It's just really slow.
So may I continue with slides while you are downloading, or do you need? Okay. Cool. So what the cubes is about? As I said, I apologize. I'm going to repeat it a little bit myself from the morning. It's about online analytical processing, or rather analytical modeling of the data. So it's for creating applications, or rather preparing data for applications like this one. You can go to this web page is Open Data Project for Public Procurements of Slovakia, which has Cubes backend, and it's reporting application where you can aggregate the data and where you can browse the data through the various hierarchy levels of aggregation. So for example, you have a report and you have split by year, and you are interested in the year, you will get the same report but for that particular year, and you will have split by month here. If you click on the month, you will have for this particular month, and you will have split by day, and so on. So it's a framework for creating applications like this. It's more about the data modeling and data browsing. It's not about the visualization. It provides you enough structured information so you can plug the information in visualization library of your choice. So yeah, it's about the modeling, the preparing the data, and reporting. The framework consists of 4 parts. One is the model. I'm going to talk about each of those 4 parts. The second one is the browser, so it's the thing who does the aggregations and drilling down and so on. The backend is the concrete implementation of the browser, because cubes by default comes, well, there are a couple of backends, but it doesn't require you to have a special data storage. It has modular architecture, and then you have a web server to create a simple OLAP server on top of your data. Yeah, so I'm sorry, I have to switch to the presentation from the morning. So yeah, the core is the logical model, which presents analyst's point of view on the data. So not how the data are stored in your application, but how business sees your data, and how analysts are working with the data. Yeah. So the thing is that every cubes-based application requires this logical model, which describes all the cubes and dimensions of the cubes. And the cubes are composed of facts. A fact is like the smallest part of your data. It can be a contract, it can be invoice, it can be a phone call or something. And the fact is measurable. So, for example, invoice has certain amount. It can have discount. It can have tax, VAT, or whatever. So this is the most detailed, measurable part of your data. And the fact has dimensions. So for example, this cube has 3 dimensions. It's time, some kind of type of contract, and location where the contract was signed. So the dimension provides the context, and it can answer questions like where did the sales happened, or who signed the contract, or if you would like to ask question how much was spent for construction work. So the construction work is like concrete value of dimension of the type of the contract. What cubes also supports, here you can try to imagine a map of Europe. So our hierarchies, and like the best example for hierarchical dimension is date or geography. So date, you might have different kinds of levels of date. In this example, you have 3 levels of date, and that's year, month, and day. But you can have multiple other levels of date. So you can divide the date like year, quarter, month, and day, or you can divide year by weeks and days, so or just year and day if you are not interested in months. And so there are many ways. Also same with hierarchies, considering geography. So yeah, the dimension defines levels, attributes. I will be talking more about key attributes and label attributes, and we will play with them. But basically, the label attribute is something which you are going to use in your application to display data to the user, and the key attribute is attribute which you are going to use to slice and dice the cube, or to generate links for drilling down into more details of the report. And the cubes is specified by dimensions and the measures. So what are you going to measure in that cube? So for in this example, you are going to measure amount, contract amount, and you are interested in aggregation of type sum. Like summarization, you might be interested in averages or minimum, maximum, or whatever. Yeah. And the model is localizable. So you can have, you will, and the thing is that you will create reporting, and the cubes will take care about the localization, so where to find your data. So it's not about only localizing the metadata, not only the model, but also you can have localized data. I'm going briefly through aggregation browser. So it's the second part, is the part of the cubes which does the aggregations, the summarization, and which does the drilling down, so you get more detail. So you can imagine, for example, this is drill down of public procurements by common procurement vocabulary, which is 5-level kind of European specification of procurement types, where you can find from uranium ore to shoes or whatever. And the browser allows you to go deeper and deeper through this hierarchy. So as I was mentioning before, the cubes doesn't prescribe how you are going to save your data or have data stored. And you can have any kind of backend, and the backend which is implemented within the sources which are available on the GitHub is the SQL backend, and there are two. This is the old one, the legacy one, which expected only denormalized table. The new one can accept the Snowflake and star schemas. So for your application, you will need the model and the data, and the browser will take care about the rest. So a couple words about cell to align terminology I'm going to use. So cell is a context of interest. So we were looking at your data. The cell is something you are currently looking at. So if you have an application like this, you have a report, and this is description of the cell. So you have this kind of selection, and you are looking at construction work and some kind of construction work, and June in 2012. So this is description of the cell. So it can be considered some kind of multi-dimensional breadcrumbs. So where are you currently looking at in your data? If something is not clear, just raise your hand and ask. The cell is defined by cuts, and one cut is specified by the path. So June 2012, you have 2012 at the level of the year, and this is June. I will go in details. We will create a model later on, but just to show you how it works. So you load the model either from a JSON file or create from a dictionary, or you can construct your model directly from classes, which is not recommended, but you can still do that if you are generating model from another application or different kind of models by yourself. Then you create a workspace. It's a place where everything is going to happen, which connects the model, chooses the appropriate browser, and connects to database, maintains the connection, and does everything around database. Then you get the cube you are interested in, and get the browser, and you are ready to go. So the basic function of the browser is aggregation, and aggregation can do basically two things. One is summary of the cell. So you are looking at construction work in 2010. So you have number of contracts and the financial amount, and drill down. So see the details within the cell. So this is how you do it. You have a browser and you aggregate the cell, and you get the summary. And this is drill down. You aggregate the cell, and you specify the dimension you are going in the details. Yeah, I will be talking about how to use the drill down later. So just to show you that the drill down is a list of records, and then you can display, and here you can see that you can use this metadata about label attribute and key attribute to easily create your report. Naming convention I will be mentioning later. Just to show another functions available in the browser, you can get the list of facts within the cell. So we would like to see the details, like all the contracts of 2010. You will do it this way. You're going to get the values of a dimension. So this can be used if we would like to create some selection box or drop down for dimension to select user the criteria for searching. And the cell details will get you information about the cell, so we can display this multi-dimensional breadcrumbs. The core function of cubes is slicing and dicing, of course, and it's like getting the information you would like to know. So for example, here's the construction work in April 2012. You have a cube, you cut it through a contract type, and you say, give me construction work and give me April 2012, and this is the cell. So this is the context of interest which I'm going to aggregate. And cube supports 3 kinds of cut types. One is point, one is set, a third one is range. Point is just one point within dimension, but it can be at any level of hierarchy. So for example, here you can see the set is collection of points, and you have at the month level, but here you have at the year level. So it contains all the months of 2010, and this contains only October of 2010. Or you can specify range for dimensions which can be ordered. Implicit hierarchy. Cubes knows which level goes next. So if you're looking at the whole data, you aggregate the cell, you get the total. If you would like to see by date, so you just say that drill down by date, you get particular months, because the first level is month in this case. And then if you select the year 2010, here you have year 2010. You have only 1 point because you are interested in only in 1 year in 2010. You get the cell and you slice it through this cut of 2010, and you aggregate, and you can see that this is the same. And you are drilling down for date. You are getting the months in the year 2010. So this makes creation of reports much easier. However, it not might be the thing you would like to have every time, so there is still possibility to specify it explicitly what level you would like it to have. So if you are not satisfied what level the cubes is going to give you by default, you can say, hey, I want month. Example of this is if you have a page where you are displaying particular month, so October 2010, but you would like to also display a bar chart of the whole year 2010, then you will use, for example, this thing. Another feature is cross table. It has not yet stabilized interface. It might change, but just to show you this feature, so cubes can do these things as well. Where you have certain dimensions as a column, certain dimensions as rows, and here you have aggregated measures, and this is how you do it. You specify the rows, you specify the columns, you specify the measures you are going to have inside the table. You get the aggregation result. Say, hey, give me cross table, and you can generate the cross table. Okay, I'm not going to Slicer now. Slicer is a web server, and let's try something with something real. So we're going now to try to create a simple tiny cube, but to be able to create this tiny cube, we need to understand how it works like and how it's stored inside. So as I was mentioning, there are multiple backends, and the currently implemented is the SQL one, and expects your data to be in a star or snowflake schema format. The star schema looks like this, where you have table with facts. So for example, these are the contracts or invoices, and these are the dimensions. So for example, this can be the date, this can be organization, this can be some product type or whatever. And yeah, so this is the star schema. And snowflake schema, you also might have master detail tables in dimensions. So this can be category table and subcategory table and so on. And of course it supports denormalized form, so we will have just one table. Well, the point of cubes is to work in like really common, not very nice environment, like considering the best warehousing practices. So it can work with any kind of data you can find around mostly. So there is no the cubes it doesn't try to put too much requirements on your data to do basic reporting. So the goal is to be ready to go in a couple of minutes. It's just a matter of creation of the model. Okay. Okay, so we are going to try to create a model, and this is the data set. If you can go to cubes source directory, and there is folder examples, and there is hello world example. Oh. Can you at least okay, so I'm going to show. So this is a table from, I think it's from World Bank. It's a really simple data set, and I'm going to show you. Give me a second. Yeah. Yeah, so we have data like this. It's really simple. We have this category code, category name, subcategory, and the year and the amount. So first, what we need is to have the data in a database. So we're expecting to have it. Cubes it's not meant to be used in production, but only for tutorial purposes, and it has a simple function, create table from CSV, where you specify the file and the fields, and it will load to a database. So it's just for playing with the data. Who has the sources, or who?
Only cubes, not cubes.
This is in cubes. This is in cubes, not examples.
Okay. So can you give dependencies once more? Because I know the cube depends on SQL architecture.
Yeah. Werkzeug.
I've got some issues with Python 2.6.
Never tried it with.
You use 2.7?
Yeah.
Because maybe 2.6 doesn't support dictionary comprehensions. So you can't use curly braces and put the objects above.
Oh.
But well, I fixed it, so maybe it should still work. If you have 2.7, it's okay. If you have 2.6, you have to just modify a couple of files.
Good to know. I mean, just a question: how important is to support 2.6?
1 out of 25.
So. So if you I don't know how to continue now. If you with the data, just continue. Okay, so just to show you, this is like the basic model. You specify the model like this. So you say, I'm going to have a cube, and the cube is going to have just one measure. Now we do not have any dimensions, and I'm done here. Now I'm... Okay. I apologize, give me a second. I'm sorry. Okay. Yeah, so we are going to try this really simple model. So we have one cube and one cube. Which has only one measure. And now we create the browser. So we get the workspace.
Are we supposed to have the Model 1 JSON available to us, or you're just showing us at this point?
Just showing. Well, yeah.
Well, you started talking about
Well, I thought that you have if you already have the examples, you can write this model just simply. Sure. So we are going to get the SQL workspace with the model we already have, and the data contained in there. Oh, what's the problem?
So for the model, we can use video model.json as well.
The model the model which is included is like the full for the thing, and I wanted to show you how to get to that model.
Okay,
So
we just extracted 2 lines or so from
Hmm?
We just extracted 2 lines from the
yeah.
Could I just ask you, because I'm a bit confused, could you just take a couple steps back and start over, like
Okay.
where we should be, what exactly we should be doing?
Okay. So I think it will be much better to do it this way. So to create a demo in that directory, and so you get the cubes, get a model, now you have the model.
I'm sorry, which one?
Yeah,
Where are you?
yeah, that's the.
We don't have the model.
This is okay.
Yeah, that's what I'm confused as well.
Okay, so create this model. Yeah.
It's just inside the procurements directory, I guess.
It's in the cubes, examples, hello world.
Is it identical to model.json?
No. This is what I'm trying to do, is to go step by step to reach the model JSON. The model JSON is the full model. And it would be much easier to go how we can get to the model instead of just explaining the model.
We'll get there.
Can you see the font size of the
Model 1.json. You're taking out of the font.
Hmm? It should be in the directory. So what I did here is I loaded the model we created here, created a workspace with a SQL backend and this database connection and the model.
It's complaining it takes only 2 arguments and 3 arguments in create workspace.
Wow. This one is complaining.
Create workspace, yes.
That's strange. We should. So it's still complaining? Oh yeah, I know. I'm sorry, my fault. You have to have name argument here. Yeah, because it's these 2 arguments you have to specify for the workspace, and the rest of the arguments are passed to the backend. So this is my fault. Yeah, I apologize. Yeah, and then you get the cube you're interested in. You get the browser for the cube, and you try to aggregate and just print the summary. So let's have a look. Let's have a look what it prints. What it prints. Yeah, so we get the result. So the aggregated result.
What do these lines do?
So what? Yeah, this. Yeah. connect to SQLite. That's where you get the SQL backend.
You have already the SQLite database.
Yeah, you need to have prepared data somewhere to be able to browse them.
There's a script prepared data.
Okay, so does it work for you? So the first model. Works? Works? Okay.
Actually, with 2.16, it doesn't work.
What is this? 2.6, it doesn't work?
No, it gives string error. What one?
I have a problem with SQLite. SQL alchemy, no such label error, ERTP balance.
Yeah, I have exactly the same thing that I'm trying to figure out.
What the
Do we need to prepare the data.sqlite? I know there's...
is there there should be SQLite, but if there is no SQLite, there should be. So they just run prepared data.
Sorry. Should there be a SQLite file somewhere in the
There should be, but it doesn't seem to be like so. Just
maybe there...
do this.
Okay,
Just run this Python prepare data.
run prepare data. Let's see if that helps. Yes, that helps. So you gotta run prepare data first. In the hello world. Right.
Yeah. So now this is not correct model, but I'm going to show you something on that.
What is, by the way, IRBD balance? Just out of curiosity, what we're looking at here.
It's some bank international. I don't know, some international bank. It's from World Bank, some kind of data. I just took it because it's just nice, simple data set to show things with 2 dimensions, one with multiple hierarchies and one just really simple and one amount. So we specify that this cube is going to have 4 dimensions. But this is not going to work. No, because you just specify that it's going to have a dimension, but you didn't define the dimension. So what you have to do is to define dimension. So as I was saying before, the model has to have cubes and the dimensions. Dimensions are shared by cubes. So one dimension can be used by multiple cubes within that model. So if you have dimension of organizations, multiple cubes can use that dimension.
So we need to add that to our model.
Yeah.
We should go to name measures as well as a dimension inside this.
Yeah. So this is the cube. So you have one cube with one measure and 4 dimensions. See?
Okay, I have done prepared tables, still have the same error. No such table. ERTP balance.
Have you run the prepared data? Yeah, so now if we have like the model contains also dimensions, and we can try it. We can try it here.
Could you explain the code a little bit?
To explain what?
Everything?
I was going line by line, so again I'm going line by line. So this is clear. I just get a model, or I can create it from a dictionary. This is to create the workspace. It's where everything happens. So it connects the model and the database together. This is the cube we are interested in. So there is only one cube in the model, so we get it. And we get the browser. So this is this is the object which is doing the aggregations. So we get it for this one cube. Because browser can retain some kind of in different backends, the browser might cache some data and so on. So this is the reason why you are browsing through one cube. And this is the aggregation. So you are aggregating.
You don't specify what field is this defined in the cube?
This is the thing. It's aggregating measures. Good question. I mean, good question. Yeah, and this is the point. This is the, yeah, and this is the thing about why it's good to have analytical modeling, because you put all the knowledge about the reporting and the analytics into the model. So you already put the knowledge about which things are going to be aggregated, and those things are called measures, and you put the measures in here. So if you're going to aggregate, you don't have to care. Everything what is measured is going to be aggregated. Yeah? So if you had multiple measures, the multiple measures will be aggregated. Yeah? Yeah, I will come to mapping later on. Yeah. Currently we are using default mapping, so it's just if you have really simple dimensions, you have the dimension name represents a column in a table, and we have only one table. So this is why I'm starting with really simple model, not to confuse you. I will show you later the model for the public procurements portal, and also the mapping and what else you can do with that.
Model definition, does that, when you're defining the cube, does that mean you drill down in that order?
No.
Is it
Well,
just a list?
Here you see only that they are dimensions. You do not see any hierarchy now.
Okay.
There are different dimensions, so it doesn't know that the category or subcategory and category are in any relationship. So this might be organization, and this might be whatever color or something, right? So this is just the dimension.
So we have to define this so that
Yeah, you define the cubes. You define the dimensions of the cubes, and you say which dimensions are going to be used by this particular cube. And yeah, we do not care about tables now. This is the analyst's approach. So how someone who is doing the reporting looks at it. He doesn't have to know anything about tables or where the things are being stored. So this is the point. You do not care about tables. You just care about your report, about dimensions, and the attributes of the dimensions. I will quickly show this because there are like more questions about the mapping, and I will skip to the mapping and show you the mapping. So how it works with the mapping. So now we try to drill down by, I don't know, by year. Yeah. And so we already defined the dimension, so I can use it. I can use the dimension. Here I have to specify the list of dimensions because I can drill down by multiple dimensions, so also by year and I don't know category. So this is like in a SQL, it's something like group by, but with a little bit of intelligence behind that, so it knows about the hierarchies. And if you look at the result, may I try it? Or yeah? Oh, where is the? No. Oh yeah. And you know why? Because it's model 3. Yeah, so we have results, but the result is iterator, so you have to get the list. And now you can see that you have 2 records. This is for year 2009, and this is for 2010. Okay, so now for the yeah.
Can you show demo as a whole, just to have a view of cubes?
Don't forget to change the model. Or if you are writing only with one model, you can do this.
You're missing the underscore. Create that underscore we're talking
Hmm? Now here we do not deal about any kind of like levels. We do not have levels yet in this model. So we do not have levels here. We have 4 separate dimensions with no relationship defined there. You know? Yeah. And before I will show you the relationships, I will have to speak about the mapping. So because now the mappings will be important. Okay. So the model, yeah.
You need like 3 screens.
Yeah. So this is the model. I mean, the next step would be the model which is included, but I didn't want it to show it at the beginning.
It's split by the year, because that's what you're drilling down by. So it aggregates speeds by the year. So add it, drill down by, you can see here, aggregate drill down equals list years. Yeah, exactly. That's
Okay, so may I continue with the explanation or? Okay. So I'm going to show you the Yeah. So how is the naming convention of the attributes in cubes? And you are referencing attributes in your reports by dimension name and attribute name. And the case we use just one word for describing the attribute, and the reason is if you have flat dimension without details, so the dimension has no hierarchy and has no other details. So for example, if you have dimension organization, you can have details like the address or something. So if you have just the organization number as a dimension, or in this case year, then only the name of the dimension is used. Yeah. And how the cubes knows where the things are stored. So there is mapping going on in the SQL backend, and mapping translates from logical, so it's like from reporting point of view, to the physical. So we had this year, and the mapping says us in which table and which column the year is stored. The company name, which table and which column is the company name or company ID or yeah. And this mapping is backend specific. If you do not explicitly specify the mapping, then the default mapping is the dimension name is also the name of the dimensional table, and the dimension attribute name is the name of the column. So if you do not specify any kind of explicit mapping, this mapping is going to be used. So you will name your dimensional tables with in the same name as the dimensions. Or if you like to add some kind of prefix, you can use the prefix, but still this is going to be the same name. The table will be named in the same way as the dimension. So this is like, if you would like to rely on an automatic mapping, then you can a little bit customize it by specifying dimensional table prefix and fact table prefix and the schema, or you can specify the mapping in a really explicit way. So you include the mappings. This is the reference for the attribute, and this is the physical reference. For really simple references, you can use it like this, and it's like dot notation with a table name and a column name. If there is any other reason you would like to have the reference more complicated, then you can specify it like this. So this is the logical reference which you are using in your report, and then you say product name is stored in a table DM products, so dimension table for products, in a schema sales, and the column, well, product name. So this is like the most explicit way how to say where the attribute is being stored in your data. Because if you are using the cubes, you do not have to know how many tables are there. You do not have to know anything about the physical implementation. You are focusing on the logical model. So, and the model is created as a business sees the data. So an analyst prepares the logical model to hide the physical implementation. There is a little thing that can be used also with mapping in the SQL. How many of you were doing a data warehousing on? Yeah. So yeah. So for those who are not doing data warehousing, it's quite common practice. Many people are surprised with that you have something like date dimension table. So it's a table with date stored because you are not using data type date. In cubes, for if you were like just to play with data, and before you create like proper date table, you can use a mapping which will extract the part of date data type. So you do not need to create a date table to have a full date dimension, like working dimension. So yeah, so we had a date dimension with 3 levels: level year, month, and a day. So we specify, hey, this is going to be stored in a column date. So if and extract from the day, extract the year, extract the month, extract the day. So this is really easy if you are just starting with that and would like to play with that without need to create a date dimension table, and it works just naturally. Okay, I will go back to the no. This depends on the SQL backend. Cubes, yeah, but and a little bit differs how they are named, and yeah. So for example, SQLite might have a little bit different set of those things you can extract from date than Postgres, and yeah, but I'm saying. You can do that if you do not have date table and you just would like to play, or for some whatever reason you just would like to try it. So it's not the best way to do that, but you can do that on a even simple data set. And I created this feature also because, as I mentioned before, people who do not know anything about data warehousing, they're really surprised at why I would need a date table to storing days, because I can use just of course, but if I have data type, so this is like to fake the dates dimension table really easily. I mean, some people find it useful, so yeah.
Where do you put these mapping JSONs?
In a cube. Yeah. So when I was saying that the cube supports SAR or Snowflake schema, so not only one table, because we are working only with one table, and for that we need to specify how to join those tables into one big star or one schema, and this is where we need to specify the joins. At this moment, Cubes is not trying to look at the joins based on the keys in the database, so you have to explicitly specify those joins. Maybe in the future it will support. So it has this notion of master table and detail table, and you specify joins just by saying, excuse me, this is the key for the master table, and this is the key for the detail. It supports only surrogate keys, so you can have key only in one column. So if your key is composite in multiple columns, you have to compute a key which will be stored in one column. So it doesn't support like multiple keys. If this notation is not enough for you, you can do as in mapping. You can specify all 3 parts of the table, so the column, the table, and the schema, and this allows you to have tables all around your database. So some people have them, so you can get tables from different schemas into one star or Snowflake to get connected. And one more thing about joins, which is supported in Cubes. If you might have this kind of problem, you have 2 dimensions, but you have only one table with organizations, and you have consumers and suppliers, and you would like to join this table. So how can you do that? Easily. You add... Yeah. Yeah. So you just add this, and then in a mapping, you're not using the table name, you're using this. Yeah. So this is like going to be new table name for the context of the. Yeah, it might be then. Yeah. Yeah. But, well, like in simple cases, this would be like enough. Yeah. And the cubes is not trying to do all the things and cover everything. It's trying to cover like the simple things that most people just need. So. It's a JSON, and I think JSON doesn't support comments.
Okay, so it's linear.
I mean, the author of JSON also explicitly said no, there are not going to be comments into JSON for various reasons. So I think one of the reasons he mentioned was that people would start put any crazy kind of meta information for processing the JSONs in the comments, and he didn't want it to do that. He wanted to have just a really simple parser for JSON. So yeah. Okay, so now we know how to do mapping, and we can go back to our model. Sure. Yeah. For the extraction of date. You're trying that. I have example where I can show you how it works. So I have an example to show you that as well. So I have an example for extraction of data. Okay, so can I continue with our simple model? So here we have our demo, and now yeah, so okay, it doesn't fit here. Is it still readable? Yeah. So, what we did here, we know that there are 2 dimensions. So if I go back to this model, this is 1 dimension, and we know that these 3 attributes are actually 1 dimension with 3 levels, right? So we have dimension called item, and here we specify the levels. And here we have the level category, subcategory, and the line item. So now we have only 2 dimensions. 1 dimension is year, another dimension is item, and we have 3 levels in that dimension. And this is what I was mentioning before. So is this clear? Like the levels of the dimension? Yeah, 1 level can have multiple attributes, and this is what I'm going to explain. Yeah, this is not the dimension. This has only this one, and these levels have multiple. No. I mean, you have like 3 levels, and like what? No. The category is a level of
I think he's theoretical, not necessarily like. If
yeah.
you were,
Yeah. No. Yeah.
Like,
Yeah.
if you could go one more deeper.
Here, well, yes and no. Yes and no. I mean, by default, if you do not specify it in other way, it takes the order you specified it here. I will show you the hierarchies later on how we specify that. So now we just take it, yes, it's like this, but it doesn't have to be. It doesn't have to be. Okay, I have a
Line item is a new entry there at that level.
yeah, it's a like lowest level of the item dimension. So this model is included in it. This is like the model which is in there, so you don't have to write it. Yeah, and now you can see more metadata specified in the model. So you can label the level, so you can use it into in your application. So you will not use this subcategory, or you will use it like this because you would like to have it displayed like this, a line item. And this part is you can localize it. Again, show it later because now it's not important how it's being done. And now I'm going to explain the attributes. You can have multiple attributes within one level. And may I switch to presentation? Yep. So there are labels and keys like recognized by cubes. The label is something which is going to be displayed to the user, and the key is something which is going to be used for drilling down and browsing. By default, if you do not say otherwise, the first attribute is going to be key, and if there is a second attribute, it's going to be a label, which makes like creation of the model really easy. You specify the first is going to be key, and the second one is going to be label without any explicit definition. And I have made a couple of tables where people usually do that. They have key and they have label. So it's yeah. If there is no second attribute, then the key is being used as a label. Well, what you can do in a model, you have really huge model, and what you can do, you can explicitly specify that not the second one, but the third one is going to be a label attribute, or the fourth one is going to be key. The order of the attributes here is only for user interface reasons. So if you would like to display them in this kind of order, so there's like no meaning in this order. And it's only if you would like to implicitly use the first one as a key and the second one as a label. But you can use label attribute is going to be name, and the key attribute is going to be some different attribute. Yeah. So this is a picture of our situation. We have this simple table with 2 dimensions. So this is dimension year, and this is another dimension called item with 1, 2, 3 levels, where 2 levels have 2 attributes and 1 level has only 1 attribute. So this is the dimension, and you have 3 levels with 2, 2, and 1 attribute. Yeah, and now how we are going to get those attributes. But before getting the label attributes, now we can go with cells. So I will come back to this later. So we can use this model. And now try to run the included aggregate.py. So we run. So what we did, we aggregated the data. We printed the summary, so the count and the summary. And here is the drill down by item. An item is dimension, yeah. No. You just use the aggregate which is there. You get like different numbers you get? You have the same numbers.
Yeah, the same numbers, but there are two different tables since it's using the model.json instead of the model we created.
This one is using the model.json.
Yeah, but we were creating model.json.
Yeah, I just... Okay, so yeah, I was saying that we are now switching to this model which is included because I already explained them. Oh yeah, we specified three levels, and now how the levels are being mapped. So this is the mapping. This is why I was explaining the mapping. So here's the mapping. So we have dimension, an attribute, and this is the column where it is specified. You have to specify it explicitly in this case because you have only one table and it expects to have a table item which doesn't exist. So you have to specify the dimension item is being stored in this attribute of the default table which is included. Yeah. Yeah, as I said before, it's not to copy the traditional way of warehousing, but to give a chance for someone who doesn't have the tools or resources to create something with properties of data warehouse, to create his own little small reporting data warehouse thingy at home or a small company. Yeah. So this is why it's light. It's not to create the competitive product to warehousing products, to lightweight alternative. No. It's lightweight alternative for simple things. Because this is what's missing. There are lots of warehousing tools and complex packages doing almost everything, but it's complicated to install. You have to study a lot to be able to do that. Sometimes writing a configuration file takes longer, and it's much more longer than writing a simple script to do this. So for simple cases, it's not that good. But for big cases and big warehouses, it's much better. This wouldn't be that suitable, maybe. So.
But we also can use separate tables, dimension tables,
Yeah. Yes, I will show you in the model of public procurements how it's being done there. Yeah. So let's go to aggregate. So now if we are aggregating by dimension item, and you can see that we get only 3 items as three records as a results. And that means that we are getting only results for the first level of aggregation. And now, if we, Okay, may I continue now to slicing and dicing to show you how the hierarchy drilling down works. Yeah, so as I mentioned before, there are three types of cuts. You have through one point or a set of a range. We are now just going to use the point, so we are interested in one particular point of the cube. And this is how you construct the cuts. So you have point cut, you specify the dimension, and you specify the path. So for example, the point is going to be 2010 or whatever. The set is just a list list of paths, and the range is from 2. Yeah, it's really simple. And then you create, if you have the cuts, you create the cell. So this is the context of interest you are looking at, and then you aggregate the cell you're interested in. So in our application here, we are creating the point cut of dimension item, and in the data see the first is the key, so we get the E. So we get the E key. We are browsing. We need to get the cell for the cube with only this one single cut, and we are doing the same aggregation as we did before. So this one and this one, they are the same. This is to show you implicit hierarchies, and we print the results. So let's try. So see, and here you can see that the cubes found the next level of the dimension item, and it is showing the quiddity. Yep. Well, if I go to data, so here you can see this one. The second one is this one, the other, and the retained. So we took the next level. So now we know how to create a model, how to do simple aggregation. Are there any questions so far? Yeah.
Is all this put down to the database, or is all the aggregation put down to the database?
No. In this backend, no. It's just like being run on the fly. It's just constructing. This is simple aggregation browser, just constructing SQL queries based on your requirements of the reporting. Yeah, and computation. So all the computations are like each request requires computation. But the SQL backend is written in a way that it wouldn't be that difficult to plug in a pre-computation, some kind of thing that will pre-compute the cube. I will show you denormalization, and with a simple pattern, a pre-computation can be done as well. I will show you also the speeds. What are the different speeds if you have the star schema and if you have denormalized table. So okay, we have the model. We know how to browse the data, and now we can look. Would you like to see how to go through hierarchies, or would you like to see the server? Server? Okay. So, where is my cursor? So for the server, you need the model, the database, and configuration. So this is the configuration. We specify the workspace. So here are the data being stored. We specify that we are using SQL. And the model is here. So basically, we need just this, right? And there is this command line tool called slicer. Okay, so we are running slicer. It's in the package. If we install cubes, you have slicer. And if we get so we get this. We get aggregation, and it contains the summary. So because we didn't specify the cell, so we are now aggregating the whole cube through all the measures of everything within the cube. Now I would like to list all the years. Oh, here's the name year. Okay, so this is the result. And I have drill down, and this is 1 year, another year. I would like to drill down by item. And this is the first level of aggregation with three items within the first level of aggregation. Now I would like to see year 2010. So now here I can see that I specified the cell with a point at 2010. And this is the result. This is the result, or I can get just the item E. So this is just for item E, and I would like to drill down through item. So now I will get the next level, and here you can see. So this is like the top level category, and this is subcategory. Yeah. So for example, if I'd like to now expand this one, the capital stock, the capital stock, in aggregation, I just add capital stock here to the path what I'm exploring. You can think of this as a directory on your file system. Really roughly, your file system is kind of one-dimensional space in this case. Yeah. So yeah, now how the details. What? This? To run the server? Or what? This? Oops. So, but if you are creating an application, your application needs to know the model. So you can get the model and you get the whole model. This model does not contain the mapping. First, because you do not want to expose your database structure to the outer world, and second one, it's not necessary for application to know what's like the physical implementation. It just needs to know what are the attributes, what are the dimensions, and this thing. So only the logical part of the model, not the physical mapping. So application will do this. So yeah. If we go to, I don't know how the internet is working. But if you navigate here, it's a databrewery.org/slicer/procurements/API. It's basically current version of API for these data in this application. If we go to tender.sme.sk, here you get the application. So we can open in two windows. This is the application, and this is like another instance. It's not the same instance as this application is using, so this is another instance. This might be a little bit slower because this is running on top of SQLite database. And if you do aggregate here, you get the aggregation here. Drill down by date. Okay, I try it with this one. Oops. Yeah, so now you can see that we drill down by date, and this model contains 3 levels of data hierarchy: year, month, and day, and you can see that it's being expanded by date. If we are interested in 2010, then we get the months for 2010. And if we are interested in 2010 January, we just add like the next level. Now we have all the days of 2010 January. Now to show you how the localization works, we get the Slovak language with the same query, and you get just the data in a Slovak language, right? Back to English. And once you get these results, it's really easy to transform the data to some visualization form for charting library or a table or whatever. This is it would be really nice to have a JavaScript library to consume that and do all the things around that. But I already started, but JavaScript is a little bit out of my scope, so never finish it. Cubes? Yeah.
Okay.
It's a young project. It's only 1-year-old project, and there is only one author with a couple of contributors with small patches to that. So this is why also it doesn't do everything. Like, it's really young, only 1 year, and I mean, so thanks. Okay, so this is how you use the server, and then so we are now looking at the January 2010, and to show you another kinds of queries to the server. So we do not have to aggregate, we can get the details, and we do not need to have the drill down. So within the same cell we get the details. So these are all the contracts. We can get the details in a CSV format, and there is one thing with JSON. in JSON, it's configurable limit for how many records you can return, and by default is like 1,000 for, don't ask me why, it's just 1,000. And there is a limit because if we would like to get the all details as a JSON, you need to construct the JSON in the memory and then to pass it away if we would like to do it correctly. But for CSV, as the records are being streamed from the database, they are directly passed. So this streamed directly to the output. So it's not stored everything in a memory, and then the whole bunch of CSVs is being returned to the server. So with CSV it's streamed. It's really fast. Okay, I don't know what's wrong with this one, but anyway, we can try. Now, do you have the examples downloaded or not? Okay, so you can hopefully yes. So let me. So if we go to examples in the procurements, you have the data, which is quite for a SQLite, it's quite a big file. You have the model, and you have the slicer. If someone has a Postgres installation, he can try the Postgres. There is a dump for Postgres database and a slicer for Postgres. I have it installed on my machine, and I will be showing you how denormalization works and how it can help you to speed up your access to the data. And also, yeah, so let's have a look at this procurement. So first look at the model. It's really a huge model with lots of dimensions, lots of levels, and lots of attributes, so it might be a little bit complicated for the first sight, so I will try to go through it slowly, and if you have questions, just ask. And before I show you the model, I show you how it looks in the database. So you have a table with, well, it's not the fact table in a pure data warehousing kind of point of view. It's just something which can be considered as a fact table. Again, this is like trying to reflect the scenarios that how the people usually have the data stored. So yeah, you have all the contracts inside and the IDs, but you have also a couple of, I would say, junk fields inside which are not interested from the analytical point of view, like descriptions or whatever. They are useful just to display the details. Then you have dimensions. So for example, this is this common procurement vocabulary, this European file level classification table, and yeah, and here you can see that it has these levels, division, group, class, category, and like the most detailed level, and the codes, and all the descriptions of the fields. Okay, so we have one fact table, a couple of dimensions, and the tables. Now let's have a look at the model. I have it here. So we have one cube here. It's called contracts. It has only one measure. It has 7 dimensions. Here is how the joins are specified. I was talking about joins before. In the future, there is planned discovery of joins. So if you have properly specified foreign keys in your table, the cubes will be able to do the joins without specifying them like this. But usually people don't have that. And this is the mapping. There are not too many mappings here because the database schema implemented inside follows the default mappings of the cubes. So if you are following how the cubes is like, dimensional table has the same name as a dimension, and the attribute has the column has the same name as the dimension attribute, and you do not need to have mapping. So here are mappings only for the attributes which do not follow this naming convention. And yeah, and this is example for the dimension. So so this is the CPU. This is the common procurement vocabulary. You can see the explicit specification, which one is going to be the key. This is the label attribute. You have three attributes of the level division. You know that this one, the label, is going to be localized in English and in Slovak. Like internal implementation of localization is really simple, because here you usually have denormalized dimension, so also the label is just in another column of the table. So we have if you have 3 localizations, you will have 3 columns for the label, for example. So it's really simple how it's being done here. Yeah, and that's basically it. Only lots of information about multiple. Yeah. So this is the model of this data cube, and you can run it locally. Yep. So this is running on top of the SQLite database with the model I was showing before, and it's getting the results. So we can get now only 2010. So we get 2010 and would like to drill down by dimension date. Yeah, and now it works. So the request was this: get me date 2010 and expand it. So do the drill down by date, and now you can see you get the months. Any questions?
If you want to have a cut of 2009 and 2010 and have and do a drill down, well, do a show it by month, how should that work? Because it's all drill down. So otherwise,
Like you would like to.
if you have another cut, because you do a range, for instance, 2000 2010.
Mm-hmm.
Does it automatically, when you specify drill down date, does it specify a year, or does it go to a month?
This is a question. Drill down currently works only if you have a card composed of points. It's not yet decided the behavior if you have range. And concerning ranges and sets, you can specify them only in Python, or if we are doing requests through a report, you cannot specify them in URL. Well, you can specify them in URL. Like, well, the range can be specified. So I can. Yeah. Or I would like to just from March 2010 and the whole 2012. So I do it like this. And I get from March 2010 and the whole year 2012, but the drill down is not defined in this case.
Can you show this by month?
Hmm?
Can you show this? Can you bring your URL where you show it by month?
Like the drill down.
Yeah, like
This is what I'm saying, that drill down when you are specifying the range is not specified yet. Yeah, so this is like a little bit of limitation that needs to be implemented later. Yeah, but it's really, I mean, yeah, you have the point.
this is kind of a rare clause, and the other one is more.
Because there is a question, what's going to be like next level if you're doing it this way? Yeah, yeah. Okay. Now the sorting is being implemented only if you have a dimension sortable by key. So unfortunately, usually only on dates dimension, because there are not so many dimensions that you can sort by key. But Arco has an idea, and also a couple of other systems have it, that you, as here you specify this is going to be key attribute, another one is going to be a label attribute, and there will be way how you would specify this is going to be a sort key for this dimension level. At this moment, you can sort only by the key. So you specify order, you will get only the key. And drill down date. And I think like this. Yeah. What you can also do, because if you are working in this web environment compared to desktop application, in desktop application, those tools have no problems with data, because they just create a cursor and you will go through that and you click like more, and there's no problem. Cubes has also ability to specify pagination. So get me page number 20 where the page size is like this. So we can do page 1. Yeah. So I got only one because the page size is only 1, and this allows you to. Hmm? It is because there was one character and yeah, like some terminal things. Because if you do the results, here's this without new line. So this is like so there was no typo. So there's this pagination. And now the cell details. This is also interesting. This is what you are going to use in your application to creating. This should be a cell. I think it's like this. Yeah. So it's a description of the cell. You get the details of the cell. And the details are by level. So this is the first level, is the year, and this is the second level. You have the month name, and also you have two. In this case, a little bit redundant, but it's much easier to use. That you directly have extracted which one is the key, which one is label, so you do not have to look up this thing in your model. So it's just for convenience to have it. Okay. So the next thing I would like to show you is the denormalization, or would you like to see, yeah, would you like to see the denormalization and the speed and the comparison of speeds, or you would like to see more about the modeling and the curing? Like doing the queries, the aggregations.
It would be interesting to see the queries that it generates and the, well,
Like the SQL.
specify so you can see the maps.
Okay. Okay.
So read the path from the URL to again what fires to the database.
Yeah, I think it's enabled here. Yeah, so here you can see. No, this was, yeah. You mean this?
Yeah. So yeah, can you explain the way everything goes from the URL?
From the URL, how it goes. So this is being translated into what we were doing in a first example in Python. So constructing the cell object and then calling browser. Where is the cursor? The browser dot aggregate, and this goes to the backend, and backend constructs the query to the database. It does the joins but what you can see here that the joins are selected only when necessary. So not the whole star schema is constructed here. You can see that only date table is being joined here. So if you do not have a denormalized view, only the joins that are necessary for the query you are doing are being used. So this also adds to the speed a little bit. So you do not have to create like the whole snowflake and then to query for a particular day or something. Yeah. I mean, this is just simple because it goes through mapping and this is being created, and that's it. There's not more magic behind that. And if you would like more magic, I don't know what it would be.
No, it's more like you have all these fields like the table name, year, dimension table, DM date.
This
Yeah, for instance that one. So where would you find that
in the model.
in the model?
Yeah. So this is the result of the mapping. So this is the logical attribute. So how we call it in the model, and this is what I was explaining in the beginning. So this is the dimension, and this is attribute. And if you have the mapping, so I'm going to show it again. So back to mapping. Mapping. So again. So if you do not specify explicitly the mapping, so this is how it's going to be done. So this is also the dimension in the table, and this is also the attribute in the column, and you can see it here. So we have date, so it's date dot year. See? But and this I'm trying, and the prefix, where the prefix comes from. So here you can like customize it. You can specify the prefix, yeah, for the dimension table, effect table, and this is stored in a yeah.
Okay, so you don't have to specify those.
No.
Those date things.
No. Yeah.
And if you show you if it doesn't, if it's not the same, where you write it in your model location wrong,
Yeah.
just to
Where is this? I cannot see. Oh, it's here.
everything is not the same as in mappings.
So yeah. Okay. Any question regarding the mappings or? No? Okay. So, so what would you like to see? There are three options. First is the normalization. The second one is the cross table, or example how you are going to use the example of drilling down through the tree of levels. The normalization. Okay.
But I'm not the only one.
Okay, so the normalization. So here we have our configuration, and then no, we have to just a second. Postgres. Yeah, so this is the configuration for Postgres. So we have the connection to the database, we have the fact prefix and so on, and by default we are using the schema I was showing. So by default we are using close, go away. Yeah, we are using this simple star schema. So now I will specify that where the denormalized view is going to be stored. Well, it's going to be a prefix. The prefix is important if you have like multiple cubes and you would like to have them like for whatever naming convention you have in your analytical database. So we have specified where the denormalized view is going to be stored, what's going to be the name, and we just use the slicer denormalize slicer PG. Okay, it exists. So okay, and now if we look in the database, we see the views. We see nothing. I don't know why. Huh. Okay. H was supposed to work. Oh yeah. Because it's in the schema named views. And here it is. So here we have the view. Oh, it's here. We have the view, and this is the normalized table. So we have only one view, and yeah. Just going to show that. I think it's this one. Oh, so well, it's not.
Inner joints or left outer joints?
I don't remember. Yeah. So. Yeah. 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 Exactly. There. Yeah. Okay, so to show you the reason, the reason for that is basically this. First is speed, and the second one that sometimes you would like to create just ad hoc reports by writing the SQL, and if you are writing the reports on top of the denormalized query, you already have the naming that you are used to in the report, so it's much simpler. You don't have to care about joins, about tables, because you already have everything in one table basically in front of you, and you can just write it. So in this example, I'm going to go to show the whole date tree. So I'm going to get all the aggregations for years, all the aggregations for months, and all the aggregations for days. Yeah. So I created a function called drill down, which takes the cell, so what I'm interested in, and the dimension through which I'm drilling down. Should I increase the font? Yeah. So if I'm at the end of the drill down, I just quit because I have nothing more to do here. I aggregate the cell at the dimension I'm looking at. I just print the rows and the drill down to the new cell, and the new cell is basically the previous cell drill down by the dimension I'm interested in, and the result is so I'm getting for all the years and all the months. It's really slow because it runs on top of yeah. SQLite. Yeah. Oh, it's just no, it's not just formatted like this. You put a couple of spaces. It's just for the terminal textual output to see. Yeah, it's like there is no other reason for that, just to put it into hierarchy. So now we are going to get the data from. Here you can see the differences of creating the workspace. It is not in place. So here you just use dimension prefix because you are working with a SQLite. Here you are working with the Postgres, and you can specify the denormalization. So, for example, we are going to without. And now we run it. This is the Python. This is the Python code. I do not have to. I need an ini file if I'm running the server. See, if I'm writing Python code, I need to craft it by hand. So this is Postgres, and we can try this. Okay. And now what we are going to do, views, how it works. Well, it might be almost the same, but okay. But if we do Okay, so coffee break.